Welcome to our second lesson in Chapter 6 on solving systems of linear equations. Today we're going to be looking at the substitution method, and here's your objective. I can solve a system of linear equations using the substitution method and can identify how many solutions there are. So substitution is simply a method, an algebraic method to find the exact solution of a system of equations. So it's a method we've developed that makes algebraic sense, that helps us figure out when two equations are going to meet on a graph, or when they both have an x and a y that are true in both equations. So let's take a look at this. I'm not even going to read this to you right now. We'll come back to it, and you can come back to it as you need to remember how to solve a system of equations using substitution. I am just going to star number 4 because this is really the biggest new thing that we have, and that is making sure that we have an ordered pair at the end, not forgetting to solve for the other variable. And I'll show that to you when we get there. So we're just going to run through a few examples together, and hopefully by the end of this, you will have a really good understanding of how to do this. So we're always going to start with two equations. And I always start by just making sure that I have them written down on my piece of paper, and I always stack them like this. Why we stack them is because of the elimination method, actually, that we're going to use next. But this is just the way you're going to most often see them. And so we like to just have them one on top of the other. Here is why I am going to choose to use substitution method on this system of equations. Like I said, you are going to have the choice of which method to use. I'm going to tell you that if I'm given these two equations, I'm going to always use the substitution method because one of the variables is already solved for. Now here's the idea, is that we have a definition of what y is. Y can be defined. Y is equal to, this also means this is a definition for y. Y is equal to, y is negative 4x plus 12. Now, if I know that y is this, and I have y in my other equation, well, I can just take this idea, this definition of y, and plug this thing in where my other y is. Now notice that this is all by itself on this side of the equal sign, and these two ideas are separated from this. So if you want to use these circles and boxes, feel free to. I always teach it like this to my pre-algebra classes because I think it makes it easier. But if this is helpful for you, go ahead and use it. I always circle the variable that is solved for, and then I circle it in the other equation, and then I box this definition of y and put it in here. Now, be careful that the definition of y is always going to be everything that is on the other side of the equal sign from this variable that I have defined. So I'm going to take this whole idea and I'm going to plug it in right here. And now I'm going to write this equation exactly how it is, except instead of writing y, I'm going to write my definition of y, because we're saying that this is what y is. It's just another way of writing it. So instead of writing it as the variable y, we're going to write it this way instead. And what do I have? I've got 2x plus, what is y? Well, it's negative 4x plus 12. And this still equals 2. So notice that this is this exact equation, except instead of writing y, I wrote what y is. Now you should be like, oh, I can do this. Like, I know what to do next. I'm going to ask you to solve this equation. Now, in this case, the parentheses don't matter. I didn't need to write these parentheses, but if this would have been a minus sign, then I would have needed to distribute that -1 before I did anything else. So what's my next step? I'm going to combine like terms. 2x's minus 4x's is -2x's. I still have this plus 12 equals 2. I have a two-step equation now. I'm going to subtract 12 from both sides. And I get -2x equals -10. Now, some of us aren't very careful with our negative signs, and if you are that person, you're going to need to fix that before you do this, because you are not going to be happy with your result if you don't. So -10 divided by -2 is a +5. Now, this is where some people say, oh, I'm done. Let me move on. X equals 5. Because all semester I've been doing that with you. We've been solving for a single variable. But we are doing a system of equations now. So I need you to take this idea and I need you to plug it back into one of our original equations to figure out what y is as well. I'm always going to use this equation that I have my y solved for already and just plug it on in. So I want to know what y is. So I'm going to say that y is equal to -4 times x. Well, x is 5 plus 12. So y equals -20 plus 12. Y equals -8. Now, one thing that I am going to do every time is check second equation, because I could have made a mistake here. I could have made a mistake here. If I did make a mistake here, I'm always going to get a solution that's going to work for this first equation. But the question is, does it work for the second equation? Let's check. Is 2 times x, 2 times 5, plus -8, is that equal to 2? 2 times 5 is 10, minus 8 is 2. Now I've checked it. Now I'm ready to write my solution. I'm sorry, we don't, this takes a lot of paper. When you're doing this on your own, I'm using a big piece of paper to do this. Finally, we're going to do step number 5 is write the answer as an ordered pair. 5, -8. And that is our solution. That is the answer that we're looking for. That is the answer you're going to give me to a system of equations. Okay, let's try the next one. So you'll notice about example number 2 is that none of the variables are solved for, but I notice in this first equation that x is going to be really easy to solve for. So I'm going to do that real quick. How do I get x by itself? Well, I just add 2y to both sides. So I'm going to do that, and I get that this equation can be rewritten as x equals 2y minus 3. Now notice it doesn't matter if I solve for x or y. I just need to make sure that I'm doing it really clearly. So my variable that I have solved for here is x. So I'm going to circle x in both of my equations. And x is this. This is a definition for x. So I am going to put this definition of x in here into the second equation where I circled my x. Now I'm going to rewrite my equation exactly how I see it, except instead of writing x, I'm going to write my definition of x, which is 2y minus 3 plus 5y still equals 24. Now I'm ready to do some algebra. I'm doing them with y's this time, and that's okay. My first step in solving any algebraic equation is to do distributive properties. So I've got 6y minus 3 times negative 3 is negative 9. I still have this plus 5y equals 24. My next step is to combine like terms. 6y's plus another 5y's is 11y minus 9 equals 24. I add 9 to both sides, and I get 11y equals 33. Divide by 11. Y equals 3. Now, we can't stop here. We've got to come up here and say, okay, my next step is to substitute the value of step 2 into the original equation and solve for the other variable. Okay, so I'm going to take this and I'm going to put it right here. So I'm going to get x equals 2 times 3 minus 3. X equals 6 minus 3. X equals 3 as well. Now, I want to check real quick to make sure that this works in my second equation. So I've got 3 times 3 plus 5 times 3 equals 24. 9 plus 15 is definitely 24. I get a true statement, which means I did in fact find the correct solution. That solution is 3, 3. Now, this point is when you are saying, oh, I've got this. I can do this on my own. Well, I at least can try until I get stuck. So I want you to go ahead and pause the video, and I want you to try it on your own. And then if you get stuck or you get all the way to the end, then please go back to the video and check your work, okay? I'm going to start moving a little faster because you're going to be doing that, and you can just pause and rewind as needed. Okay. First thing is, there are several things you can do with this. Probably the easiest thing is to just see that this second equation, it's really easy to solve for any of the variables. You could also see that you can divide by 2 up here and make this a little easier if you want to, because x plus y equals 4 is the exact same equation. It's all up to you. I'm just going to do the simplest thing, and I'm going to subtract x from both sides, and I get y equals negative x minus 2. Now, if you would have solved for x here, that wouldn't have been wrong. You should get the exact same solution that I did. If you would have solved for one of the variables up here, that wouldn't have been wrong either, and you're still going to get the same exact solution as I did, just as long as you did everything correctly. So I solved for y, so I'm circling the y's in both equations. Here is my definition, and I'm putting my definition in here for y. And I get 2x plus 2 times negative x minus 2 equals 8. I need to do distributive property. (2x minus 2x). Uh-oh. What happened? Those go away, and I get negative 4 equals 8. Now, I'm going to tell you that if this ever happens to you, first, check to make sure that you did everything right, because this will not happen very often. I've had so many students in the past say they make a mistake, and then they say, oh, it's just no solution. Well, that's not usually the case. But in this case, it is. If you notice that if you divide by 2 up here, you're going to get x plus y equals some number, and x plus y equals some number. That means we've got the same slope, just different y-intercepts. If you would put these in both slope-intercept form. Another good way of checking this is to write this in slope-intercept form. You're going to see that you're going to have y equals negative x what is that going to be? Plus 4. Okay. Notice same slope, different y-intercepts. Oh, no, wait. Hold on. That shouldn't be the case. Subtract x. Subtract x. Yep. Okay. So, I'm just making sure that I didn't do anything wrong here before we move on. Okay, yes. So these are parallel lines because they have the same slope but different y-intercept, which means there is no solution. Now, I went through a lot of work explaining to that and getting myself a little confused for a hot second there. But all you need to know is this. If you get a false statement, if you get something that is not true, no truth. I don't know why I wrote no truth. This is not true, which means there is no solution. There's no moment in time where we are going to have an x and a y that are going to be exactly the same. So if you get down here and your variables go away and it's a false statement, then you have no solution. Now let's take a look at this one. I see that it's really easy to solve for x here. X equals negative 2y plus 6. Now I have x solved for, so I'm circling for x. Here's a definition for x. I'm plugging it in here where I see x. So I have 3 times what x is, minus 4y equals 28. Distributive property, negative 6y plus 18 minus 4y equals 28. So I have negative 6y and negative 4y, so that makes a negative 10y plus 18 equals 28. I'm doing some algebra here. I'm subtracting 18 from both sides. I get negative 10y equals 10. I'm dividing by negative 10. Divide by negative 10. Y equals negative 1. Believe it or not, I am not done. I need to come up here to my original solution and plug y in because I need an x. So I get that x equals negative 2 times what y is. Well, it is negative 1 plus 6. X equals 2 plus 6. X equals 8. I'm going to check to make sure that this is true. And when I plug it in here, I get 3 times 8 minus 4 times negative 1 equals 28. And 24, negative 4 times negative 1 is a positive 4. 28 does in fact equal 28. That is a true statement. So I get this point 8. 0.8, negative 1. And that is our solution. Okay, so that was a lot. I'm not going to make us do this back page on this video. What we'll do is we'll just use this as a warm-up during our next class. So please let me know if you have any questions, and you should know what you need to complete next. Thank you.